Hello, everyone. Thank you for joining us today for session 2 of our introduction to A2L refrigerants. We're going to give everyone another minute or so to join the webinar, and we will begin promptly at 2 minutes after the hour. Good afternoon, everyone. Thank you for joining us. My name is Tom Deary, and I am the Director of Codes for the Air Conditioning, Heating, and Refrigeration Institute. AHRI is the trade association representing manufacturers of heating, ventilation, air conditioning, refrigeration, and water heating equipment within the global industry. AHRI represents more than 330 manufacturers of air conditioning, space heating, water heating, and commercial refrigeration equipment and components. And we're so glad you're able to join us for today's session. Before we begin, I would like to share the following disclaimer. The opinions expressed in this presentation and on the following slides are solely those of the presenters and not necessarily those of the Air Conditioning, Heating, and Refrigeration Institute. AHRI does not guarantee the accuracy or reliability of the information provided herein. This presentation is for general informational purposes only and does not constitute legal or professional advice. Please confer with your own legal counsel. Please also note that today's session is being recorded. The discussion topics that we will cover today include standards updates for HVAC equipment, standards updates for commercial refrigeration equipment, model code updates, and we'll have time at the end for Q&A. You may submit questions using the questions button. We will answer questions as time permits, but I will also provide contact information at the conclusion of today's session, and I encourage you to reach out to me with any questions. Additionally, both the recording and the slides from today's session will be made available on AHRI's Safe Refrigerant Transition website after today's program. Now I would like to introduce today's presenters. We have Harshad Inamdar, Research Engineer, Advanced Research from Ream Manufacturing Company. Ron Sugart, Compliance Engineer Project Manager from Heat Transfer Products Group. Andrew Klein, Consultant with AHRI. And Kevin Scott, Consultant with Johnson Controls. Thank you all for joining us today. And with that, I will turn it over to Harshad.
Thank you, Tom. And good morning, good afternoon to all attendees. In my section today, I'll be covering standards updates for HVAC equipment. Next slide, please. Yes. So the safety standards that are important for HVAC equipment are ASHRAE 15, ASHRAE 34, and ASHRAE 15.2. These should be the standards that are important for AHJs and code officials as you perform planned review and inspections on site after installation of the equipment. ASHRAE 15 is the installation safety standard that covers all types of equipment and applications in non-residential installations, and then a limited number of residential installations, such as centralized systems installed in multifamily buildings or systems serving common use areas in multifamily buildings. And then ASHRAE 15.2 is the installation safety standard that covers HVAC systems in residential buildings, in residential installations. So from single family homes and two family homes and townhouses to individual dwellings in multifamily buildings. Then on the left-hand side, you can see two standards are shown together. That's because ASHRAE 34 is packaged with ASHRAE 15. And then ASHRAE 34 assigns designations and safety groups to refrigerants. So for example, when we talk about a group A2L classification or R32 or R454B, so this designation and the safety classification is assigned in ASHRAE 34. So now ASHRAE 15 and 15.2 use these safety groups or this safety classification when prescribing requirements for safe installation and then safe operation and maintenance of equipment. Now, where to find these standards, right? So ASHRAE actually provides free read-only access to all of these standards on the website shown here. And if you have, for example, an ICC Premium Digital Code subscription, so ICC is the International Codes Council, right? And so if you have a premium subscription from ICC, you should be able to access these standards there or wherever else that you prefer to purchase these standards. Addenda, errata, and interpretations for all of these standards are also made available by ASHRAE free on the same website. So for example, if for ASHRAE 15, there have been more than 20 addenda published to this edition, and all of those should be available on this website. There have been 3 addenda published, or 4 addenda published, ASHRAE 15.2. Until now, they are available there. And so all of this information can be found on the ASHRAE website. With respect to interpretation, so for example, if you find a particular section of the standard confusing, someone else may have found the section confusing as well. Someone else may have asked the same question to the committees who maintain these safety standards, and those interpretations are also available there. So the ASHRAE website is a really good resource to find information on these safety standards. And then finally, the current edition of these standards is the 2022 edition. Usually these standards are updated on a 3-year cycle, but just on a one-off basis. A new edition of this standard will be published this year of all these standards in 2024 to better coordinate with the model code development cycle. Next slide, please, Tom. Okay. So another standard is important for HVAC equipment, which is the product safety standard. Now, UL 60335-2-40 is the product safety standard or the listing standard for air conditioners, heat pump water heaters, heat pump pool heaters, dehumidifiers, and air conditioning chillers. An AHJ or code official should, in normal circumstances, should not need to refer to these standards because these standards really apply to the equipment manufacturer, and any information that's relevant to installation, safe operation, safe maintenance is required by the standard to be written in the manufacturer's installation instructions. So the information that's needed by the code official should be present in the manufacturer's installation instructions from this safety standard. And then the product safety standard also prescribes some requirements for auxiliary devices such as electric heater kits or UVC germicidal lamps. And this information relevant to these auxiliary devices should also be should also be present in the manufacturer's installation instructions. Next slide, please, Tom. Yes. So EPA's SNAP, so that's the Significant New Alternatives Policy Program. EPA approved the use of Group A2L refrigerants in HVAC equipment in SNAP Final Rules 23 and 25. EPA also prohibited the use of these Group A2L refrigerants to retrofit existing equipment. So where EPA approved the use of Group A2L refrigerants, EPA clearly states that this approval is for use in new equipment specifically designed and clearly identified for the refrigerant. And then EPA also requires equipment using Group A2L refrigerants to be certified to UL 60335-2-40, the product safety standard we discussed on the previous slide. The next slide, please, Tom. So now when a code official or an AHJ performs plan review, one of the things that you would verify is the refrigerant charge limit or the minimum room area. And the concept is that the releasable refrigerant charge in the equipment has to be less than or equal to, so it cannot exceed the maximum allowable refrigerant charge for a given space. Or in other words, the minimum floor area required to install the equipment, or the actual floor area in which the equipment is installed and the equipment serves has to be greater than or equal to the minimum floor area required to install the equipment. And so the way to find what the releasable refrigerant charge is it can be found in the installation instructions, or we can use a method prescribed in the safety standards we discussed previously. And the same goes for the minimum floor area required to install the equipment. That is, the manufacturer is required to provide this in the installation instructions, or the methods prescribed in the safety standards can be used. So if we sort of briefly talk about releasable refrigerant charge, the releasable refrigerant charge is the quantity of refrigerant that can leak into a given into the indoor space served by the equipment. And it usually, so as you can probably guess, the releasable refrigerant charge is less than or equal to the total system charge in the equipment. And the reason that it can be less is if a manufacturer incorporates some control, such as a pump down control, for example, or installs some components such as safety shutoff valves or isolation valves in the liquid line and vapor line, such that some refrigerant charge in the equipment can be isolated, can be prevented from leaking into the indoor space. Then the releasable refrigerant charge is less than the total system charge. Yeah. And the approach to ensure safe installation and safe operation is really, it's based on the concept that even in the case of a catastrophic release where the entire system charge leaks into the indoor space, the refrigerant concentration will not exceed the lower flammable limit for the refrigerant. And not only should it not exceed the lower flammable limit, but it should remain below this limit with a safety factor. And so that is how the standards have been that is how the requirements in the standards have been developed. And these requirements, the safety measures that are required to be incorporated in the equipment, they have been validated through several HRI research projects, whose reports can also be found on the HRI website. If some of this seems complicated, there are easy to follow flowcharts in ASHRAE 15 and 15.2, which can be used. Then further, there are requirements in refrigerant piping in ASHRAE 15 and 15.2 that must also be complied with. Next slide, please, Tom. Yes, so here, methods that we talked about in ASHRAE 15 and 15.2. So these are snapshots of maximum allowable refrigerant charge tables in ASHRAE 15 and 15.2. And you can see the tables show, given a floor area, what is the maximum allowable charge that can be employed in an HVAC system serving that space. And then if safety features are incorporated in the equipment design, such as circulation. So we can see some of the tables show columns with circulation, without circulation. So that means circulation can either be continuous circulation airflow or circulation that's activated by a leak detection system. And so if ventilation is provided, so for example, table 9-4 in ASHRAE 15.2 on the right-hand side, or table 7-4 in ASHRAE 15 on the left-hand side, we can see that there's a ventilation airflow rate corresponds to a certain charge quantity. So if the refrigerant charge quantity exceeds what is the maximum allowable charge based on floor area, then mechanical ventilation can be provided to safely diffuse, disperse, dilute any leaked refrigerant. Warning labels will be provided on the equipment that clearly inform the installer of what the minimum floor area is. And these warning labels are required by the product listing standard as well as by EPA in the SNAP final rule. The next slide, please, Tom. And there are some special requirements that apply to appliances that cool information technology equipment or computer room air conditioners, which can be found in Addendum T to ASHRAE 15. If equipment is installed in institutional occupancies, such as hospitals, in nursing homes, so these are occupancies where the occupants cannot quickly leave the space. So there are some special requirements that apply to such occupancies. And then equipment that we mentioned previously, so air conditioning chillers, they are commonly installed in machinery rooms, and those machinery rooms must also comply with different requirements which are found in ASHRAE 15. Next slide, please, Tom. Yes. And now we're transitioning to sort of the inspection phase. So a marking must be applied to equipment that contains Group A2L refrigerants. So the red square, the flame inside the red square, that's the familiar OSHA pictogram. And the flame symbol inside the yellow triangle, that's optional. And then the refrigerant safety group must also be marked on the equipment. So if you're inspecting an inspection, you can quickly recognize that this equipment contains Group A2L refrigerant. Next slide, please, Tom. Yes, so warning labels must also be applied on the equipment. So if some safety features are incorporated in the equipment that are required for safe operation of the equipment, the installer or you as the code official, you can easily see that such safety features are provided, and they must remain electrically energized for safe operation. And yes, so these warnings are required by the product safety standard, and they should be easily seen and understood by the installer. Next slide, please, Tom. Yes, with respect to accessories that may be installed in the field, there will also be a warning label on the equipment informing the installer that only approved auxiliary devices can be installed in ductwork. And the installation instructions should list auxiliary devices that are approved by the manufacturer. And the reason is that some auxiliary devices, such as electrostatic air cleaners or germicidal lamps, can become potential sources of ignition depending on their surface temperature or if they produce electrical arcs or sparks. So that's the reason why the equipment manufacturer approves auxiliary devices by confirming that they are not ignition sources. Next slide, please, Tom. Yeah. So a label will be available on the equipment that the installer can use to basically create an inventory of the total system charge. So how much is the charge that was charged to the equipment from the factory, then if any field adjustment is necessary, add that charge quantity to what was factory charged, and then note the total refrigerant charge in the system. And so when we perform the minimum room area calculations, or when we make sure that we are not exceeding the maximum allowable charge for a given space, we can use this total charge, this label, this total charge that's actually charged to the equipment to make sure that we are complying with the standard. And next slide, please, Tom. Yes, and as we, as I said in some of the previous slides, all of this information must be provided by the manufacturer in the installation instructions, such as the minimum floor area. And the safety standard requires the equipment manufacturer to provide this in as a single value or a table, so without using equations. And so for the installer or for the code official performing the inspection, all of this information that's needed to ensure compliance with the safety standards should be available in the installation instructions as well. And yeah, so that's the end of my section, and I'll transition to Ron.
Thank you, Harshad. And up next, we'll have Ron Sugar to talk about standards updates for commercial refrigeration equipment.
Okay. Okay, first slide, please. Yeah, today what I'm going to speak on is more of, give you a little bit of an update or overview. We're going to talk about the standard for commercial refrigeration, UL 60335-2-89. Next slide, please. This is the safety standard that UL has given us to cover the equipment for refrigeration. And in this case, mostly commercial refrigeration. It will also include ice makers. It will include cases. It will include remote refrigeration. But again, now we're having a whole standard just for commercial refrigeration. Next slide. This standard, as it says in here, is a dual national standard. It came, we're currently on the second edition. It was published in October of 2021. It covers commercial refrigeration. This makes a division. Previously, we had UL 1995, which covered air conditioning and commercial refrigeration. It has now divided those. And it realizes that these are two separate products and have a lot of differences. This also allows the use of A2L refrigerants, which we never had before with commercial refrigeration. It also allows for A3 refrigerants to go from 150 grams to 300 grams. Next slide. Did I say 500 grams? Excuse me, I apologize. It's based on the third edition of the IEC code, i.e. the European code, which was developed in June 20th of 2019. As you can see, Europe has a few different items covered there, but it basically is commercial refrigeration and ice makers. Next slide, please. The goals for 2-89, 60335-2-89 was a harmonization. We wanted to harmonize all of the standards that covered commercial refrigeration and with the Canadian standards and with, as we saw in the previous slide, IEC standards, the European ones. It also, again, creates a standard for commercial refrigeration to include these flammable refrigerants. A2Ls, again, were never covered before for commercial refrigeration, and now they are. It was also allowing the A3s to go up to the 500-gram limit. Next slide, please. In our harmonization, which I mentioned, we harmonized quite a few standards. Any of you who have seen these before noticed that we had a standard for unit coolers, a standard for refrigerated units, either self-contained, a standard for refrigerators and freezers, one for ice makers, and again for heating and cooling equipment with 1995. We standardized all these, and again, 1995 was the air conditioning portion was removed, and now it only affects commercial refrigeration. Once this harmonization was done, we then had all these standards to take care of. Next slide, please. We sunset, all these standards will be now sunsetting. And by that, it means that these don't go away. It means that new products cannot be listed to them. In other words, if a product currently exists, a unit cooler, a walk-in, a condensing unit, an ice maker is already listed in any of these standards, as long as those manufacturers do not make changes to that equipment, they can continue to produce them, and they will produce them to the standards that they already were working upon. However, if they make any changes at all, they will have to list their product to the new standard, the 2-89 standard, 60335-2-89. Next slide. This is a very busy slide, I realize that, but it illustrates that what happened when we decided to make this change and all these sunsettings, that all the national refrigeration testing laboratories, i.e. UL, Intertech, and CSA got together and proposed dates that these standards would go, and I don't want to say they go away, they just sunset, and that's a very key term here. And as you see, as in the very last date on the slide in the bottom right-hand corner, as of September 29, 2024, all new product will have to be listed to UL 2-89, 60335-2-89. Okay, next slide. Why did we go through all this trouble? I mean, we've had some of those standards for years and served us well, but now we are faced with some new world. We had to transition to low GWP refrigerants. And that forced a new standard to have to be made because none of the old standards covered them. The transition was a phase down mandated by the AIM Act that came out in 2020. And it is required by the EPA guidelines that we make this transition. And it now is refrigerants are allowed by the SNAP rule. As Harshad said, it's the significant new alternates program. The Rules 26 just came out. This is the commercial refrigeration SNAP rule. It covers or it allows the use of these refrigerants. I've listed some of these here. This is not a complete list. I'm sure that some of you, if you know this, will know that there are other refrigerants, but these are the main ones. For the A2Ls, the mildly flammable, we're going to see these refrigerants out, mostly 454C, R454C, R55A. They have a low GWP of 148, and 454A, GWP of 239. Their applications are detailed in the SNAP rules. 1234YF is also out there. Again, these are the main refrigerants we'll see. A3 refrigerants, mostly we're talking about propane. It's very low GWP, but we are limited to the amount of refrigerant to 500 grams with the new SNAP rule. Next slide, please. Coming with these new standards, we're going to see some new terms and some new things occurring. They're a little different for commercial refrigeration than what Harshad covered in his air conditioning terms. we're going to be working under these three mitigations. We are also going to be using that lower flammability limit. That's a formula, as you can see. It's contained in ASHRAE 34, what each refrigerant's LFL is, and each refrigerant has a different LFL. So if it's 454A, 454B, 454C, each one has a different lower flammable limit. To give you some idea what these are, an M1, which is our lowest mitigation level, very small equipment, about 7 pounds. M2, we're looking at about 35 pounds. This is a medium-sized piece of equipment. And for our largest, we're looking at about 175 pounds. This will be what your circuit charge will be, your maximum circuit charge to fall into these mitigation levels. Next slide, please. Now, we just said about these M1, M2, and M3, and this gives you an idea of what we're looking for. As Harshad said in his, they're looking for some of these with the M1 is the room area. This may also include air circulation, i.e., if you have a walk-in box, you may be leaving the fans running to circulate that air. Usually this is in that small amount of charge, 6, 7 pounds. M2, if we get up into that level, in those 35-pound level, we'll have an A2L sensor, and I'll give you a picture of that in a moment here, and we will have air circulation. If we get up into that 175 level, we'll fall into an M3 mitigation, and at that point, we can use an outside force ventilation. In other words, you may have an exhausting fan on your walk-in box that will blow the refrigerant out. If it's in some other place, again, it will be an outside exhaust fan. And now I do want to make sure that it's fairly clear that as we go into these mitigation states, the compressor will shut down. Therefore, no more refrigerant will be pushed out to the system, and it will allow it to mitigate. Once the leak has been mitigated, and i.e., it goes back above its lower flammable limit, or that 25% of lower flammable limit, the compressor will return to refrigeration, and it will again process. If the leak occurs again, we'll go through the same process. Next slide. Talked about a little bit about this is a new requirement for 2-89. It also will be in 2-40, but we will be using an A2L refrigerant sensor. It senses the A2 refrigerant, and it alarms once the room concentration, or what it senses, is above a 25% of that LFL. So we're not even going to get close to the limit that we saw before, that lower flammable limit. We're going to only be at 25%. What the process is as soon as this sensor senses a refrigerant of that 25%, it will go into that mitigation mode. What happens is it'll turn off the compressor. It will keep the fans running in a case of a walk-in box or whatever else, and it will continue the circulation. And if the charge has been determined to be above or in that M3 category, it'll turn on the exhausting fan. Okay. Next slide, please. With refrigeration equipment, it's going to be more common to see shutoff valves. What we're going to do is plan on, and it'll be included in our installation and operation manual, as Harshad mentioned, all these things will be shown, but we're intending that a set of shutoff valves be included or be suggested for each of these products, like a walk-in box. The walk-in is its own separate room, if you will. If we put a shutoff valve, i.e. a solenoid valve before and a check valve after, we can limit the amount of charge that could possibly leak to whatever is in that walk-in box. We can then have a much lower mitigation, and we can have a much less chance of any more refrigerant leaking out. Next slide. In addition, and Harshad again also talked about this in his slides, but also we will be putting markings that these contain A2L refrigerants on them and A3s. I've shown here the A2L refrigerant, the red triangle and the red diamond. And these will be placed anywhere there is a connection to the piece of equipment, i.e. a service valve, a charging port, and those will be marked. In addition, we will have red paint. As shown here, you can see the red cap, but we will actually be painting a little bit more than that, but it will be either some marking of red around those ports. That way the service technician will know instantaneously that he is working with a flammable refrigerant, either it be mildly flammable with the case of the A2Ls or flammable with the A3s. Again, additional markings will be on these units, warning markings in the case of A2Ls, and they will be danger marks in the case of A3 refrigerants. Basically instructing who should be working on these. They'll be in different languages, and some of the things that you should and should not do. Most of these, there was also markings that will state to the installer that he should be looking at the installation operation manual. He should be qualified to be working on this equipment. There will be some differences between an A1 refrigerant that we now see and an A2L. Of course, one is mildly flammable and one is low flammable. Definitely different things will have to be taken into account. Next slide. Just to give you, again, I mean, I don't want to leave A3s out of this, and I know I spoke mostly about the A2L refrigerants, but the A3s, refrigerant, these are pieces of equipment that are factory charged. Again, 150 was what we had. Now we have 500 grams to work with. Still a small charge. That's just for some of you out there. It's basically moving from about 6-7 ounces to about 1.1 pounds. So it's still not a lot of charge. There will still be some special requirements for points of egress, i.e. hallways and corridors, and those will be limited down to 114 grams. All right, next slide. Give you a little bit of the future. These UL 60335-290-89 is a living standard. It is not going to be the one and only. We're currently working on the 3rd edition. We're making improvements. As you saw, we incorporated 6 different standards, actually 7 different standards in this harmonization. And some of these standards had different rules, and now we tried to harmonize those. So we're looking back at it again and trying to make it even a better standard. And I would imagine we will continue to do it until throughout the life of this standard. Currently, like I said, we're working on the 3rd edition. We're planning on having that out sometime this year, maybe the first part of next year, Q1. We're hoping for a general comments in February of 2025. That's the plan right now. And if we get those out for comments, we're hoping for a publication of this in the time frame of June, maybe July of 2025. And I believe that's my last slide. Thank you.
Thank you, Ron. Up next, we're going to get into the model code updates, and our first presenter for the model code updates will be Andrew Klein. Andrew, I think you're muted. Andrew, can you hear us?
Tom, can you hear me now?
Yes, we can hear you well.
Okay. Sorry, I was trying to use my headset, which worked earlier. So, yeah. But anyway, thanks, Tom, for the introduction, and thanks everyone for joining us today or watching the recording. So I'll kick off the codes update summary. The two significant codes regulating the design and installation of mechanical systems are the Residential Code and Mechanical Code. The International Residential Code, often referred to as the IRC, is the commonly adopted code throughout the country, and it covers single-family homes, duplexes, and townhouses up to 3 stories in height, including their accessory buildings. All other buildings are regulated by the Mechanical Code. There are 2 organizations that develop and publish the 2 mechanical codes commonly used throughout the country. Those are the International Association of Plumbing and Mechanical Officials, or IAPMO, which publishes the Uniform Mechanical Code, or UMC, and the International Code Council, or ICC, which publishes the International Mechanical Code, or IMC. All of the codes are published every 3 years, and the most recently published editions, which we're talking about today, are the 2024 editions. All 3 codes are aligned with the 2022 edition of ASHRAE 15, and in addition to the listing requirements to the standards that Vikas and Ron spoke about, the major revisions include requirements for the use of A2Ls in direct systems and machinery rooms. Next slide, please. So Ron and Vikas did a great job overviewing the updates to UL 60335 parts 2-40 and part 2-89. All codes have been updated to reference the 22 edition of 2-40 and the 2021 edition of 2-89 due to the sunset of UL 1995 that Ron spoke about. I'll also mention that IAPMO missed the reference to update UL Part 2-89, so they still reference the first edition in the model code, but that's being corrected and has been corrected during the adoption process in states where it's used, including in California. Part 2-40 covers air conditioners and heat pumps, and Part 2-89 covers unit coolers and commercial refrigerators and freezers, including walk-ins. The scope of the mechanical section in the IRC does not exceed the requirement that systems be listed and labeled to UL Part 2-40 and installed in accordance with the manufacturer's instructions. So the remaining slides summarize the additional design and installation requirements that are found in the IMC and the UMC. High probability refers to a system where the air is in direct contact with the evaporator, meaning that a refrigerant leak can result in a refrigerant entering occupied areas. These include the typical rooftop unit and split systems, as opposed to systems that use an intermediate fluid such as glycol. High probability systems are limited to refrigerants with safety group classifications A1 and A2L. There are 4 exceptions that exist, as are broadly shown on this slide, for industrial occupancies and for A2 and B2 refrigerants in limited quantities in other occupancies within listed systems. And of course, a very limited amount of 150 grams of A3 refrigerant in listed self-contained systems. So that's not been updated yet to the 500 grams that Ron spoke about that UL Part 2-89 has been updated to. The mechanical codes have a table of refrigerants that's extracted from ASHRAE 34 that lists the classifications, the amounts of refrigerant, including the refrigerant concentration limit, or RCL, lower flammability limit, LFL, and the occupational exposure limit, OEL. These tables have been updated with all refrigerants in the 2022 edition of ASHRAE 34, and it's worth noting that 2Ls are no longer considered a subset of Class 2 flammability classification as they had been previously. The OEL, which is regulated by OSHA, was added to the table in 2015, and that's the concentration in parts per million that's safe for constant exposure to a worker during a 40-hour work week. New language has also been added for machinery rooms for A2L and B2L refrigerants to avoid the need for rated electrical equipment. Open flame producing devices and continuously operating hot surfaces over 1,290 degrees Fahrenheit are prohibited from being permanently installed. Refrigerant detectors are required to signal alarms and activate the ventilation system to ASHRAE 15 level 1 within 5 minutes of reaching the occupational exposure limit, and to ASHRAE level 2 within 15 seconds of reaching the refrigerant concentration limit. Clearly identified switches of the break glass type or other approved tamper-resistant cover must be provided to shut off refrigerant compressors, refrigerant pumps, and normally closed automatic refrigerant valves within the machinery room. In addition to the manual stop, this also must be automatically triggered upon the detection of 25% of the refrigerant's lower flammability limit. An additional manual switch of the same type is required to activate machinery room ventilation fans. Of course, all normal signs, charts, and labels required by the fire code are still required on the refrigeration units and systems. Refrigerant pipe material and installation language has also been added to the mechanical codes. Refrigerant piping is prohibited from installation within exits, fire resistance rated exit access corridors, and within shafts containing moving objects such as elevators and dumbwaiter shafts. Where piping penetrates 2 or more floors, it's required to be enclosed in a fire resistance rated shaft enclosure that's ventilated. Refrigerant pipe shafts with A2Ls and B2Ls can be naturally or mechanically ventilated, as opposed to refrigerants with a class 2 or 3 flammability classification, which must be continuously mechanically ventilated. When installed in studs, joists, rafters, and other similar members within 1.5 inches of the edge, shield plates are required to be installed for all refrigerants other than groups A1 and group A2L. With the exception of self-contained listed and labeled systems, stop valves are also required to be installed at the suction inlets and discharge outlets of each compressor, compressor unit, and condensing unit, and also the outlet of each liquid receiver. Lastly, the requirements have been added to the mechanical code that include a visual inspection and testing prior to refrigerant pipe being covered or enclosed. Testing with a 10-minute hold time is required with an inert gas, such as nitrogen, helium, or argon, to the lowest design pressure of any system component in the system. Periodic testing of emergency ventilation fans and detection and the alarm system can also be required by the code official, but it's not prescribed by the code at any specific cadence. And that concludes the overview of code updates to the residential and mechanical code. So I'll hand it back to Tom to introduce Kevin Scott.
Thank you, Andrew. And lastly, we will have Kevin Scott talking about the updates to the 2024 IFC, IBC, and the 2024 edition of NFPA 1.
Thank you, Tom. And we're going to switch now from the mechanical codes to the fire, building, and other codes. We have and what we're going to talk about now is the current code editions of the International Fire Code, International Building Code, that being the 2024 editions, and NFPA 1, National Fire Protection Association Fire Code is NFPA 1, and NFPA 55. That one is the 2023 editions. But all of those codes have been updated to recognize A2L as a separate category, separate from A2. All previous editions of those codes, the A2L was included, but it was included as a subset, essentially, of A2 refrigerants. In these current editions, the A2L now has separate, is listed and acknowledged as a separate classification, and it has separate requirements. Next slide, please. So currently, as A2L, it is considered a flammable gas. It has a new classification, or there is a new classification under the Global Harmonization System as a Category 1B, because it has a burning velocity of 3.9 inches per second or less. It is considered a mildly flammable gas, and as was discussed in session 1, it is a low flammability. Yes, it is a flammable gas, but it's a mildly flammable gas, 3.9 inches per second. It means you have a cloud of gas, as the flame front moves through that cloud at 3.9 inches per second, you can walk faster than the flame will move. It will not explode. It will burn. It will not explode. So because of that, the quantities that are allowed, the maximum allowable quantity per control area, is vastly increased. As a liquefied gas in a non-sprinkler building, you can have 10,000 pounds. Building sprinkler, 20,000 pounds. So the quantities, when you compare to other flammable gas, vastly increased. As a gaseous stored commodity, I can go all the way up to 325,000 cubic feet in a sprinkler building. These are the quantities that are allowed in basically any occupancy. There are some other allowances that are allowed when it is a Group M or Group S occupancy. Next slide, please. For Group M or Group S, there are some other allowances that are allowed based on the typical retail marketing style. Basically, in retail setting or mercantile setting, everything is within reach. In other words, as I walk through a retail store, I'm going to pick the product I want to buy. So the concept is everything's within, and based on these configuration requirements, maximum storage height, 6'6". So all of the products I'm going to buy are maximum storage height 6'6", and that becomes one of the restrictions here for these particular requirements. But because we're going to limit it to 6'6", we're allowed to increase the quantities because we're going to spread out the hazard. So these criteria for Group M mercantile, Group S storage allow increased quantities, but have additional restrictions that go along with these increased quantities. Next slide, please. So under this, we have two options. We can store to 6'6" in my Group M or Group S. I can store up to 6 feet on shelving, but the shelves have to be metal. I don't use shelving. I'm just going to stack product, maybe pallets or solid pile, whatever it may be. I can go to 6'6". I use shelves, maximum storage height of 6 feet. If I store above the A2L gases, everything stored above, well, I should say this in reverse. Nothing stored above can be combustible. So there's no combustible products stored above the A2L flammable gases. If there's flammable liquids also stored in this facility, they have to be separated by 20 feet horizontally. This 20-foot separation can be reduced to 10 feet if I provide secondary containment or diking so that a flammable liquid spill is contained and separated so it cannot get closer than 10 feet to the flammable gas, the A2L gas. Next slide, please. If I want to go above 6'6", I can. What do I have to do? Do I go above 6'6" in retail? Sure, I do. Go to a Costco. I have to do everything I just did before, but I changed the sprinkler design. I go to an extra hazard group 1 sprinkler system design. I'm going to provide more water, a lot more water in my sprinkler system design. And the 6'6" limitation goes away. But and goes away. So let's go now to the next slide, and we'll look at the differences. Because in this one, and just so you know, in the table, the blue number 390 cubic feet is highlighted for a reason. If you're using the 2024 fire code, it doesn't say 390 cubic feet. The building code does, NFPA does. The 2024 fire code says 39,000. It's a misprint. It's an error. There is an errata. It should say 390,000 cubic feet. But in my non-sprinkler building, I can have 20,000 pounds. If I sprinkler it per footnote 2 is below, it says sprinkler with ordinary hazard group 2. And I can double the quantity. I'm still limited to 6'6". Let's go to the next slide, please. If I provide the extra hazard, okay, next slide. We're running out of time. Let's go to the next slide here real quick. If I provide this this extra hazard group 1 sprinkler system, the top is the ordinary hazard group 2, which is a typical retail sprinkler system design. It provides 0.2 GPM over 1,500 square feet. 0.2 times 1,500 square feet is a minimum of 300 gallons per minute. Extra hazard is for a higher fire load, but it allows me to increase the storage height. It requires 0.3 gallons per minute for 2,500 square feet, which means a minimum of 750 gallons a minute. 2.5 times the amount of water minimum. But it allows me to exceed the 6'6" storage height. So if I go that in a new facility, I could design it that way. If I have an existing retail facility, I'm most likely going to have the standard storage design of ordinary hazard that I can provide. Let's go to the next slide, please. So we have another footnote that we can provide. Footnote C says, if I exceed 50,000 square feet in my control area, for every square foot over 1,000 square feet, for every 1,000 square feet over 50,000 square feet, I can add 2%. So in this case, my control area, my building or my control area, it does not exceed 50,000 square feet. So It's sprinklered. I met the sprinkler requirement, so I got 40,000 pounds of liquefied A2L. That's the maximum in my control area. And I can have that in there. Next slide, please. But this one says, here's our footnote C. If I exceed the 50,000, I can increase it 2% for each 1,000 square feet that I go over. So if I have a 60,000 square foot warehouse, I've exceeded the 50,000 by 10,000. So I get to take credit for that 10,000 square feet, because now I can spread out. Basically, I'm spreading out the hazard. I get 10,000 square feet to spread it out further. I get 10 times 2%. I get 20%. I can add 8,000 pounds to that. Next slide, please. I can go up to 100% maximum. I cannot exceed 100%. So when I reach 100,000 square feet, I can actually double the quantity. So in this area, one single area exceeds 100,000 square feet. I've already doubled the 20,000 because it's sprinklered. I got 40,000 on the left. I'm now using footnote C also because of the size of the control area, and I get to double it again. Now I'm at 80,000 square feet in my one area. And I said 80,000 square feet, 80,000 pounds in that one control area. Next slide, please. I can have 4 control areas on the first floor. So I have a 1-story building. In this case, I just made it simple. Each control area is less than 50,000 square feet. So I'm using just one of the footnotes. I had it sprinklered. So I'm doubling the quantity allowed in each control area. The 20,000 pounds allowed is doubled in each control area. I have to separate each control area with 1-hour fire barriers. I'm allowed 40,000 pounds in each control area. I have 160,000 pounds in my building. Next slide, please. This is the table where we started. Under liquefied in a non-sprinklered building, I was allowed 20,000 pounds. That's where we started. I moved to the right-hand column because it's sprinklered. I doubled it. And that's the quantity per control area. I'm allowed 4 control areas in the building. I increased that times 4. I got 160,000 pounds in my building with 4 control areas. If each control area exceeded 50,000 square feet, I could also use footnote C to increase that area. Question now. I'm going to answer a question because you're not yet in the 2024 code. Can you use these quantities today because the jurisdiction has not yet adopted these codes? The answer is yes, if it's done under an alternate method. All of the codes, International Code and NFPA, allow for the use of an alternate method, but it has to be applied as an alternate method, whatever process the jurisdiction has set up for receiving, reviewing, and processing an alternate method. And I think that's my last slide, Tom, and I think we need to stop there.
Yes.
I don't know what we want to do about, there we go, questions.
Thank you so much, Kevin, and thank you to all of our presenters. We have exceeded our time allotment here, and so much great information, and I'm truly appreciative of all the work that our presenters put in today and their willingness to share their expertise. because we have exceeded our time, I do want to encourage folks. I'm going to provide my contact information. If you have questions, please send them to me. And if you have any questions specifically for any of our presenters, I will be happy to put you in contact with them so that they can answer your questions as well. I do, before people have to drop off, I want to remind everyone we have one final session left in this series. That is Wednesday, June 12th, 3 p.m. Eastern, and that'll be A2L Refrigerants Part 3, State and Local Codes and Available Resources. We will have Robert Glass of Daikin Comfort Technologies and myself, Tom Deary. We will be the presenters, and we're very much looking forward to that as well. So look for registration on that. We'll be sending out registration info as we did for the previous 2 sessions. I also want to give a plug for our A2L Refrigerants Building Codes map. We have an interactive map, and if you use the QR code on your screen, it'll take you there, and that'll have information on all the different the status of the state and local codes in each state, and if there's been legislation passed that allows for A2L refrigerants to be used, or if there's been a letter issued by a jurisdiction that allows it. All of that information will be there if you simply click on one of the states. It will bring up all of the relevant information. It's a great tool, and it also has my contact info as well. So if you come to that map and you have some questions about what you see there, I am always happy to answer any questions about that. It also has all of the standards that were discussed today by Harshad and Ron. What edition of each standard is currently adopted by a state? That can be found on that map as well. So hopefully you'll find it to be a useful tool, and any questions that arise from that, I'll be happy to take as well. And to that end, here's my contact information. Tom Deary, once again, I am the Director of Codes. My email address is there on the screen, as well as my phone number. So if you have any questions about any of the material that's been shared today, or anything else pertaining to A2L refrigerants or codes, always happy to chat. So please reach out to me on behalf of both myself and AHRI. I want to sincerely thank Harshad, Ron, Andrew, and Kevin for volunteering their time and expertise today. And again, look forward to chatting with anyone who has any questions about A2L refrigerants and the A2L refrigerant transition. And we will look forward to seeing all of you back on Wednesday, June 12th for part 3 of the A2L refrigerant webinar series. Thank you and have a great afternoon.